What's up, ladies and gentlemen? Mr. P again, and I am putting this video together as sort of an overview and review of what we did in Unit 1, Investigation 2. Remember, we are not going to be going live on October the 14th because I'm actually going to be in school. I'm not going to be able to meet with you guys, I'm just making this instead. Remember, we are going to be having our quiz on Thursday, October 16th. 15th. Get my days mixed up. So in investigation 2, we had 3 big questions. 1, how can charged objects have an effect on each other without touching? 2, how do factors like distance and the amount of charge affect the interactions between objects? And 3, how does our model of charge interactions connect with a variety of phenomena? Okay, so starting in Act 1, how do charged objects affect each other? And this is where we started to get the idea of an electric field. Okay, I have 2 positive charges here, and I really like these simulations that were laid out. They're both here on Schoology and on the Interactions website. But I can select this trace option, and what this is doing is tracing an electric field. An electric field is sort of a, can produce a force on an object in 3 dimensions anywhere around a charge. And we can see here, obviously this is in 3 dimensions, but it goes 360 degrees around on our computer screen, around that positive charge, in this case pointing away. I could also flip this around. I can make this a negative. I can see this arrow just flipped around. Okay, now instead of the arrows pointing away, the arrows are pointing towards. Okay, and we can assume that these arrows are sort of going to tell us which way this positive particle is going to go and interact with this negative particle. It makes sense. If we have both positives, it's telling me that this positive is going to go away. In this case, it's going to go up and to the right. Down here, it's going to go almost directly to the right. Over here, it's going to go down and to the left. Right? So wherever this positive particle that I'm dragging is, it's going to go directly away from this positive particle. And likewise with the negative. Wherever this positive particle is, it's going to go directly towards that negative particle. So again, in activity 2.1, we started to get an idea of what an electric field is, right? So the answer, how can charged objects have an effect on each other? It's because all charges have an electric field around them. In activity 2.2, again, another really good simulation here. Our question in Act 2.2 is, how do these factors, including distance and the strength of the charge, affect the field and the force? So we can see our field is illustrated here by these green lines. The other thing that it's adding here is it has these yellow lines which are illustrating the forces. So the first thing that we looked at was distance. And as I drag these particles further and closer to each other, I can see that those arrows change in size. So if I have them really, really close, those arrows get really, really large. Whereas if I drag them further away, those arrows get a lot smaller, right? So the closer the charges get, the stronger those forces get. The further they are away, the weaker the force is going to be. The other thing we could look at with the simulation is the sort of amount of charge, the size of the charge on each particle, right? We can make each one all the way down to a -3, all the way up to a +3. So if I just made a +1 and a -1, I can see that, again, the error is very small. As I ramp them up in their respective directions, change it to a +3 and a -3, those arrows got a lot larger. So now I can say, as the size of the charge gets smaller, the force gets smaller. As the size of the charge gets larger, that force gets larger as well. And then to finish off with Act 3, 2.3, excuse me, there was a demonstration looking at a setup called Franklin's Bells. And I went over that more in depth in a separate screencast I'll be publishing as well. But what it's talking about is the difference between how things are interacting in a field and how charges can change when they are in contact with each other. So to quickly review, we have the Van de Graaff off to the side here. It's connected by a wire. We've got 2 soda cans. Right now, this is off, which means that everything is neutral. If I fast forward here, they plug the Van de Graaff in, and that, because this soda can is attached by a wire attached to the Van de Graaff, it takes on the same charge, right? When things come into contact with each other, they receive the same charge. Part of the reason why our experiments in investigation 1, we didn't want them to touch. We didn't want them to exchange charges. So as this one can becomes charged, that originally neutral object that was hanging in the middle starts bouncing back and forth. A really important thing here is that it's touching the cans. Like I mentioned just a second ago, when this object touches the first can, it receives that charge. So then it bounces over to the second can. And then it's sort of exchanging those charges, which creates it to bounce back and forth. Okay, so that's a quick overview of Acts 2.1, 2.2, and 2.3. Quickly, I wanted to show you around what's going to be in our review folder. At the end of 2.3, there was a check for understanding, and there was a matching portion with some of our vocab. I listed all of the vocab terms here. Again, this is not really, these aren't really Google definitions. These are based on the observations and the experiments that we've been doing in our class. So how they work specifically with the language that we've been using. Okay, so if you open that up, it's just a Google Doc. It has the bolded vocab words and then the definitions that they should have matched up with. Okay. The second thing here, there's a link to a separate screencast I just finished explaining more in depth that Franklin's Bells demonstration. This is a link to the video that I am making right now. So I'll have to fix that in a sec. And then you've got a practice quiz. Okay, and it should be set up for you to take it as many times as you need to. And again, it's going to look very similar to the quiz that should be coming up on Thursday. So, as always, shoot me any other questions you have either on Teams or on Schoology. I'm not 100% sure how much I'm going to be able to be at my computer tomorrow. I know Thursday I'll be back, and I'll be open for questions and things like that. Friday, you guys do technically have school. You'll be able to complete the quiz through Friday afternoon. So I hope this helps. Again, just want to go over what we saw in investigation 2 as we wrap up. And as always, shoot me some questions if you've got them, and I hope to see you guys soon.